So again, Adnan Sahin and Vince Westin talking about VMAX all-flash data services, and we appreciate the time to talk here at Storage Field Day. So what are we doing with data services? We have snaps. What I talked about with the snaps is we have the ability to make 256 snaps of all of the 64,000 devices in the box. Right? So the snaps act as versions. Rather than having them create new LUN IDs, which is what a lot of the products do, the snaps act as versions of the primary device. And so they hang off the device and you can track them all that way. Because again, how else would you find 2 million snaps and what they're supposed to do? So they're hanging around as versions of the primary. And then if you want to mount them, you associate them with another device and you mount it to a host. The good news about that is when you associate it, what you mount is the other device, not the snap. So the snaps themselves are pristine. They are immutable. They cannot be changed. There's no way to actually mount the snap itself. There's no way to modify a snap.
But I can spin up a clone from a snap.
Right. You can link it to a device and mount it, and all the rights go to the mounted version. They don't go to the actual underlying snap.
Yeah.
So the snap itself stays pristine. And that's important because we have a lot of customers who need to be able to make sure that their snaps don't go anywhere.
Does that mounted device count against my 256?
No, but it counts against the 64,000.
Okay.
But it's not one of the 256. And you can do a linked snap, linked snap, linked snap, linked snap as deep as you want to go.
Okay.
Right? No limits.
And they're redirect on write snaps?
Yes. Well, all the entire box is redirect on write. Right? Even the primary volumes, you write a new track, will redirect it somewhere new.
Yeah.
Because you got snaps, yeah.
Right in free space, yeah.
Yeah. Couple other things. All the snaps.
The integration of the snaps integrated with apps and DBs.
Yeah, so we've got AppSync and some other tools that can do linkage, so you can make sure that you've got Oracle relationships or whatever else, and you can mount the copies and make all those things happen. If you want to mount test copies, we've got RMAN integration pieces for backups. Right? Lots of things we can do to make your snaps easier to use.
Okay. Yeah.
One of the things, if you're going to make hundreds of snaps per array, you don't have to go clean them all up. So you have automated expiration of the snap. So each snap has a time to live when you create it. So you say, keep this one for 2.5 days, keep another one for 6 hours. Right? If you're creating lots of snaps, most of them are probably going to expire in a day or less. Some of them may be longer. So this gives you a way to easily set that up so the array itself will go back and clean all those things up, and you don't have to actively try and manage it to keep the snap count sane within the system.
If I click advanced there, is there a consolidate snaps, so take a snap every hour but keep one per day and one per week?
We don't have a nice scheduler for that yet. We're working on that.
Okay.
But yeah, but if you do snaps once a day and then you do intervening hours, when the hours go away, they're all consolidated anyway.
Yeah, but I want it in one, it has to be in one policy because it's a lot of work otherwise, but
yeah,
I'll take.
So it's somewhat schedulable, and we have REST APIs.
Yeah, I was going to say.
Right.
Yeah.
So
I'll just write a chef recipe and we'll be fine.
Exactly. We also have this graphic that talks about the ability to create secure snaps. So when you create a secure snap, basically what you say is you cannot delete this snap before it expires. You can't shrink the expiration. You can extend it, but you cannot shrink the expiration date and cause it to go away. We designed this because we have multiple customers who do backups of air gap systems where once a day they'll do an air gap backup. Right? The problem is if the bad guys come in within the 24 hours, you can lose a lot of data. So with this, you can do backups, snaps every 10, 15, 20 minutes, right? Whatever you want to do across the day. They're all secure. They can't be deleted. You make sure you keep those past the time of your next air gap backup. Done. Right, so keeping the bad guys from, even if they have control of the array, they come in and say, please delete all these snaps, and the array just kind of laughs at them and tells them to go away. Right, so the bad guy can get all the API controls they want, they can try and do whatever they want, they can't get past this. So it's just, it's another option for interesting things to do.
Is that completely immutable, or is it a super user that can?
So again, the snaps were already immutable, this is the you can't delete. If you want to delete those, you call us, and with the right authorizations at the highest level.
4A level immutable.
No, because they can do it.
Okay,
If you are, my array is out of space and I'm dying and my CEO needs to make a call, you can get somebody from EMC service to get the right authorizations to come in and free up snaps.
So not 17.4a.
And do you support point to multi-point replication of those snaps? Is that possible?
We do replication of the primary devices, but you can create snaps on both sides. Yeah.
But is it possible to take a snap and replicate it to a remote site?
You can snap to a device that replicates, yes.
But then you can't get rid of that snap on the primary.
No, once you link it up to the other device, it'll make a copy of the data into the.
Oh, and then it'll make its own instance.
Okay, I'm
go.
not sure what I get by what you mean by snap to a device that replicates
You link it to a device.
replicate the primary and
No, he only wants a copy of the snap, not the. He wants to take the snapshot, which isn't a device. You have to link a local device to that snapshot. Now that becomes live. Then you use that as the base. That's the
replica.
primary for the replica, so that you don't care about the live. You want that one piece of it that doesn't change.
Okay, and if
it's
I want
like a one-time shot.
and if I want to do this application consistent, I take an application consistent snap,
That's a
turn it
whole
to a
other thing,
device,
yeah.
replicate that device, snap it at the remote.
Yep.
Okay.
Protect point is the ability for the array to talk natively to data domain. So you take a point in time backup in the array and we push it to the data domain over fiber, sending them only deltas. And if you want to restore, that's the real trick, right? Is I can now restore a system that may be a quarter petabyte or a half petabyte for a single database. I can restore that in a time that's meaningful to the business because I can be doing that restore at full bandwidth of deltas, right? Of only the changes. So most customers are going to do that with snap restores, right? Not from outside the box, but this gives you the ability to say, hey, gee, this array went away. I can now do the same kind of restore to a different box, right? And do that at full bandwidth and bring it back up. So lots of options there for high performance backup. As we look at what we're doing for backups, right, we have a customer who did a massive reduction in their backup time from 17 hours to 3. And of course, the move from an older hybrid array to an all-flash array, the latencies just all drop to sub-millisecond, and away you go. So we have a lot of customers who are very interested in how do we do these very large backups for critical systems like Epic Healthcare. Right? How do we make the backup? How do we do the restores? Again, the backups are the easy thing. The restores are the real pain. And that's where we can make a real difference for the customer on what they see for effective timing. Non-disruptive migration gives us the ability to pick data up from one array and move it to the new one. So this started off being from older arrays. We can do it from VMAX to the hybrids to the all-flash. We can do it between systems. Basically, this is like having Metro, SRDF Metro, which is an active-active, between the two frames. Our older arrays did not understand Metro. So we play special tricks with SRDF to allow this to happen. But your old array will donate the LUNs to the new array, including all the worldwide name, serial number, and everything else information. So the LUN remains the same and keeps the same host properties. So the server will see new paths to the LUNs. They'll be able to come up and read write to them. So that you create the new copies, you cut over to this new array, and then when you're sure everything's safe, you commit and you're done.
What about NAS?
This is for block.
Thank you.
On the NAS side, we do have embedded in with ENAS, we have the virtual data mover mobility, and you can do copies of the NAS and you can move the virtual data mover between things, which will move the IP addresses and all that as well. So
you got to flush DNS cache. There's some operational. It's not as non-disruptive.
It's not as non-disruptive, right, but it can get there pretty quickly. Interestingly, for iSCSI, we can actually move the iSCSI endpoint with Metro. So once you get to our new VMAX 3, VMAX all-flash iSCSI implementation, you can do the same thing with Metro and just bounce LUNs between arrays, and the servers don't even need to use the multipathing because we move the IP address with it, right? We move the whole SCSI endpoint. So iSCSI actually makes it easier, which is
so in
kind of
situations
fun.
where you have very large environments where you're using almost the max number of LUNs in a production system, and you try to do that, obviously. How do you design a non-disruptive migration where you may run out of LUNs?
I don't have many customers running more than 20,000 LUNs in a frame.
Oh, okay.
It's really not a problem we've got.
I was thinking
general.
more on the fabric end, from like VMware. You can only see so many LUN paths.
So yeah, but VMware is doing the very large LUNs, right? In general, most of your ESX implementations, yeah, you've got ESX implementation issues, but you do this move, right? My ESX server's here, now the storage is here. I haven't changed anything about the ESX. Right, I'm not adding new LUNs to ESX. I'm just moving where they live.
You're adding paths though in the process.
Yeah, but you can generally add a couple of paths and move things over and drop paths and make things happen. If you're running 4-way paths, you might drop to 2, add 2 new ones. Right, you can make it work.
What type of LUN sizes are you seeing out in the wild with vSphere for all-flash VMAX?
So again, I have a lot of customers who are sticking to, they've migrated older things and they've got 8 and 16 and 32 gig LUNs. And I've got other customers who do nothing but 60 terabyte LUNs, right? They just do giant LUNs because they don't want to manage them, right? And they have, when you're doing 950s with petabytes of data, give me a bunch of giant LUNs I don't want to think about. Right?
What's the average that's recommended by EMC?
We don't really care. we don't have we recommend that you have at least 10 to 15 active LUNs per path so that you have enough to keep queuing away, right? So making one big 60 terabyte LUN for your ESX server, you're going to have queuing challenges, right? Making 100 tiny LUNs for your Oracle database is a lot of overhead you don't really need, right? So it's more about how do you get enough parallelism for your application. We don't really care what the size is. And again, you can online resize them, so you can also start off with, I've got 20 LUNs, that does really well, I've got lots of parallelism, they're at, half terabyte each. Now I want to add more space. Okay, I'll update them all to be 600 gigs instead of 500.
And
right?
that's online resize?
Yeah, online resize, go.
Expand only, yes?
Expand only, yes.
Say reduction? Okay, that's impressive.
Right, we don't do the throw data away.
Right.
We only do expand. And again, we migrated over 10 petabytes of this in the first year. It's been very effective. Customers really like the ability to non-disruptively move on to new frames.
45,000 devices there as LUNs, not source arrays, right?
Right, devices, or LUNs, yeah.
Okay.
4,000 migrations, 45,000 LUNs. Open Replicator is still here, so if you have some things that need to be upgraded to VMAX, we can do that and suck the data across live. So you take a brief pause in your application, we start the data sucking into the VMAX, then you bring the application up and run while we suck it over in the background, right? So you can do minimally disruptive outages to move things onto the new platform. You can use that from almost any block device. Right, so that works very nicely. 1,000 LUNs at a time, included as part of all VMAX licenses. And if you happen to have PowerPath already on your host, we can do this non-disruptively. Right, so lots of great stuff there. SRDF. This is why people buy VMAX. Right, people say that I buy SRDF and then I buy VMAX hardware to run it on. The synchronous replication, obviously you write to the source, it writes to the target, the answer comes back, you're acknowledged, you're right, you're done. It's all done synchronously, it's all very happy. Metro is a special use case of synchronous. In the Metro environment, we do the same thing, but we do it from both directions. So the LUN is read-write on both frames. And just to be clear, the LUN isn't preferred on either one. So if you do a write on the secondary array, it does the local write, it sends it over here, it comes back, acknowledges, and done. There isn't one array that owns the LUN. It is equally shared across both. And you have the witness there, so if one array can't talk to the other, you talk to the witness and decide who wins, right? You also, if you don't have a witness, you can just set bias. The bias array wins. So, you can choose how you want to do it, but it's available with Metro to be able to integrate it however you'd like.
Is bias an array function, an array level function,
LUN.
or a LUN level function?
LUN level.
Okay.
So you can, for each LUN, decide where you want it to live.
Just for path, really, right?
Well, it's per LUN. For each LUN, you can say, do I want this? If things fail and I don't have a witness, which one stays live?
I see. Yeah.
Right?
Well, if I'm in the Metro, I want I want to set bias to
that makes sense.
the array that's physically with the server that is
Right.
accessing the data.
Yep.
I guess you can
Assuming
do-
that's the array that's going to live.
Well, if
Right.
the other one died, well, bias only worked. Yeah.
Right.
do that
That's
by-
why you've got witness and you can do more complicated things. With async, we talked earlier about that. So you locally write, we acknowledge, we buffer it up, we send it. What we do that's very different is we do not keep those IOs in order. Right? We do write folding and all those things, and we say this is the start of the change, and then whatever your timestamp is, 5, 10, 15, 30 seconds later, this is the end of the change. We take all the changes and send them to the target. On the target, we apply all or nothing.
Okay, so it's effectively point in time.
Right.
like a snapshot.
So it's
Snapshot.
a snapshot. It's a snap ship where I'm just taking my deltas and shipping them across and applying them. Right.
For the entire world of storage consumers, let me say to the entire world of storage vendors, that there's real-time asynchronous with write order integrity, and there's point-in-time snapshot-based replication, and you people should stop calling one the other.
Okay.
It is not specifically a Dell EMC thing. This is everybody overclaims that their point-in-time is asynchronous. And yes, it is asynchronous in that it is not synchronous.
Right.
But there is that middle thing that exists, and the term asynchronous should belong to that.
What do you mean when you say 2 site, 3 site, 4 site? So I can do a Metro active among more than 2 sites?
So you can do 2 metros, and then you can have async hanging off of one or both. Right.
Okay.
So you can do multiple sites.
So the synchronous and Metro are 2.
Yes.
And then you can do asynchronous.
Right.
Okay, fine.
Yep.
That makes sense.
Do you support near sync?
No?
Do I support what?
Near sync.
No, you got sync and async. Again, you can run, if you've got 2 boxes that are close to each other and you're just trying to avoid the overhead of sync, you can put this in a 5-second cycle, right? And that's near.
Yeah. Do you find many VMAX all-flash customers are also using vPlex?
Not many at this point. Again, what a lot of folks were using vPlex for was either for mobility or for active-active.
Yeah.
Now that we have NDM and we have Metro,
It's built in.
it's there in the VMAX, right? And then there's one less thing to manage. The other challenge we've had, of course, is that the VMAX now pushes a lot more bandwidth. You might have to attach 2 vPlexes to the front to manage a single VMAX because of bandwidth or IOPS. So, yeah, that doesn't. And then you say, now my vPlex is supposed to scale to handle multiple what? The math doesn't quite work there because the vPlex hasn't scaled.
Yeah.
It's still only doing 4 nodes, and we're doing 8, and we're driving a lot. We got newer CPUs and all that, so yeah.
And we got a question from the Twitters about SRDF and VVols and VASA 3.
Okay, so we support SRDF with VVols. We do not have the VASA 3 provider at the moment. That is something that is in planning. Again, can't talk roadmaps, but it is something that's in planning.
Real soon now.
Yeah. A couple of special things about RDF. We do enhanced RAID. So above and beyond what you have with your local resilience, you have SRDF. It is a remote mirror. So if your local RAID group were somehow to fall flat, we would read the data from the remote one and do rebuilds from the remote data. Right? That is not optional. It is automatic in every SRDF configuration, whether it's synchronous, asynchronous, doesn't matter. And if you go to the IDC paper we have posted on the webpage, you can read on page 29 how they ran a test of this. They went in and pulled 2 drives out of the same RAID group, and their I/O patterns just kept right on running and running off the remote array and done. Right? Nothing special to set, nothing else to do. So it is mirroring on top of your local RAID for both frames. And it's something that's been there since we first did SRDF in '94. Multi-array consistency, so you can have up to 64 arrays in each data center and have your data be consistent when you're doing asynchronous replication. So part of the reason we're doing the snap shipping, as you say, is to make sure that when we do the cycles, we can cycle switch all the frames at once with minimal impact. So we have customers running 20 frames in Atlanta and 20 in Austin, or 8 in Texas and Atlanta, 20 between New Jersey and Tennessee, and a variety of other configurations. Right, where there is consistent data, mainframe open, whatever, across all of this, bidirectional. Have a nice time. Right, SRDF scales unreasonably. Right, we can do the largest configurations in the world. That's why people buy SRDF. Right, and with Metro, you can bounce applications back and forth between arrays. So again, we talked about the forklift. Right, whether I'm using Metro or using NDM, it's easy enough to pick an app up and move it from one frame to the other. The application doesn't have to go down, so you don't necessarily care.
What about backwards compatibility of SRDF? So if I'm running VMAX 2, VMAX 3, and I've got all flash, SRDF is backwards compatible?
Right, the SRDF we're running on all flash is compatible with every VMAX ever made from the original VMAX 1. It's not compatible with the old DMXs, but they're all off support life now.
Right.
So, as we go forward, we try and keep at least 1 or 2 generations of backward compatibility. So we can talk back to the old 76 code just fine, even on the latest all-flash boxes. And
that's
as
the
we
same
do
with
new things,
compression
we
as
intend
well.
to keep doing that. Yep.
And that's the same even with the compression applied.
Yeah, because all that's internal with the drives, right? When you bring it up to the cache, it all gets uncompressed. So the remote box doesn't care, right? So it's fully compatible, and that's again how we can do the migrations, right? I can set up RDF under the covers for NDM. I move into a new box, the data lands, I compress it, done.
So you guys are abstracting away all the version-specific stuff underneath the covers.
Yep.
That's how you're able to stay consistent on top.
Right. Well, the old box is running 64K tracks. The new box is running 128K tracks, right?
Nobody
I mean, the old guys are running stripe metas. The new box is single LUNs. We just lie to the old box. And just like we lie about compression, we lie to the old box. Yeah. I'm a stripe meta. Oh yeah, I'm 64K. Yeah, don't worry. Come on, give me the data.
You're virtualizing it all on the top.
Yes. We just try to make it easier, right? Simplify all that. And for Metro, you can do cross connect or you can do local connect. Either way, we don't really care. You got all the apps can run on top of this. So we have mostly Oracle Rack and ESX stretch clusters are the most common use cases for this because they're the real active things. But you can do other types of clusters as well, right? But you can do stretch rack across 2 data centers. Rack can't tell the LUNs aren't local, and away you go. So similar to what we're doing with NDM, right? When you do a Metro copy here, we copy the worldwide LUN name and all that LUN information to the target array. So it looks like it's the same LUN on both frames. So if you do cross connect, you see the same thing. right?
So
Nobody
you-
has to worry about how to figure out that it's different lines.
So you're taking the serial number of the source array across with you in the worldwide name? Okay.
Just bandwidth questions. We're talking all
There
flash.
goes all
We're
of
talking
the, and I
metric
want to know
distance.
exactly where my data stuff.
How many
where my data
can I
is stuff
assign
we were
to that
talking about a couple of years
replication
ago.
Yeah.
So SRDF, we usually don't use more than 8 or 10 ports on a single array for remote replication.
Okay.
But if those are fiber channel ports, that's a lot of bandwidth.
Yeah.
Right? So, one port per card, multiple cards, scale it out. We've got customers who drive, 50, 100,000 items a second per frame, remotely replicated and done. On
Street to Jersey City.
yeah,
Did you get fiber channel yet?
we're 16 at the moment.
So Vince, I have to ask the question that if you're passing the serial number worldwide name across between arrays that are physically different in serial number,
Right.
why aren't you just virtualizing that serial number and creating virtual arrays that can move anywhere around the infrastructure?
So right now we're virtualizing the LUNs, but we have done that. All the VMAX 3 serial numbers for the devices are created dynamically, and if you delete one and recreate, you'll get a new serial number for
Right.
the LUN. So we've separated the LUNs from the hardware. But again, we have a lot of customers who have history and they know how to find the serial number in the worldwide name.
Yeah.
And so we're working to retrain everybody on that.
Yeah,
But you could make that completely virtual and just say, I'm going to have a virtual array which belongs to a customer, or from administrative purposes, move that around the physical.
We've looked at that. Again, on the iSCSI side, that's easier. You move the IP addresses and it moves.
Yeah.
In Fiber Channel, trying to move worldwide names around, you got to then do really virtual endpoints and all that stuff, and it becomes a little messy.